Hello and welcome back to part 2 of this unit testing series. If you start with this part, then just welcome, and maybe you want to look at part 1 first. In either case, we are going to take the theory that we saw in the previous video and apply it to do some actual unit testing. So we're going to cover JUnit, which is a tool to write the code to do the unit testing. I showed you very briefly an example in the previous part. We're going to do a little bit of setup. So how do we actually set up our unit testing? And we're going to look at some tools included in this JUnit, specifically these helper methods, which helps us because they're helper methods. So that's what they do. All right. So before we jump in, a few comments about how to structure your unit test. There is the AAA approach, which means that we want to first arrange, then we want to act, and then we assert. And we try to write our unit test to follow this. So here we set up the test case. Here we execute some functionality or some methods. We call methods or whatever we do. This is where we actually do something. And finally, we assert, we verify that the result of doing the act part is actually what we expected. Arrange, act, assert. So that's the structure of our tests. And I see sometimes that my students will do arrange, act, assert, arrange, assert, act, assert, arrange, act, blah, 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 so on. And that means you have done way too much in one unit test. Because we want to test as little as possible per test method. And this is where I would usually ask, why is this relevant? And well, if this was a physical class, or session in class, the point is that if I write a very elaborate test method and it fails, the question is then, is it the actual code that I'm testing? Is it my functionality that does not work? Or did I make a mistake in my test method? Do I now have to write a test method that can test my test method, which tests my code? And so you see, that's not what we want. We want to test as little as possible, because then we can be fairly certain that if something fails, it's not the test that's wrong, it is the code that I have written that's wrong and needs to be fixed. And it will also be easier to understand the tests and what they do. So keep it simple. Keep it simple, stupid, I guess. All right. We basically want to test one thing per method, but sometimes that's not entirely possible. So we may have to accept that I'm going to test two methods, or at least if I test one method, it indicates that I assume the other method is actually working. And that has to be okay. That's what we need to do. So that's what we do. But again, as little as possible. All right. We don't want to have any dependencies between these test methods. Not between them. And usually we don't want to have dependency to client server connections or the database either. Because this creates an outside dependency that can change. Maybe I run the test on a different computer where I'm using a port number that's not open, so my test will fail, but it works on one computer, not the other computer. So the same thing if I do not have access to the database, or if I'm not careful, then one test will modify something in the database. It will then fail, so the test does not clean up in the database, and then the next time I run it, my test data is still there. So you have to be very careful when you test something that involves either the client-server connection or the database. I don't really see this very often. The database connection is more often used. I have seen semester project groups do very thorough unit testing on the database, and they were that was very well done. They would create a method that would create an entire dummy database, and then before each test was run, they would reset that database back to that test state. All right. The reason we don't want dependencies between tests is that the tests are run in random order. No, maybe not entirely random, but you cannot expect them to be run in the same order every time. So if I do something in one test and expect my second test to depend on the first one, sometimes the second will fail because it runs after or before the first one, and sometimes the run order is reversed and it will succeed. So no dependencies between tests. Try to minimize it on client server, and be careful when you do it with a database. You have to set up a quite elaborate testing system, which can be very beneficial if you do that, but it can be a bit difficult. Okay, so that also leads me to that everything should be stateless, meaning that you create what you need and then you delete it after each test. And we can use some annotations here, which I will show you. We can mark methods to help us clean up. And then a naming convention. Usually you should name variables, methods, classes, something meaningful, something so that you can get an impression of what that variable holds or what the class does or method does. For the tests, you should write the names so they provide as much as possible about the intention of the test. So that means your names can be quite long, and that's okay. Okay, so that's some theory about the structure of our unit test. Try to write the code so that we first arrange everything, then we act upon it, and then we assert that the acting provides the result that we expected. We want to test as little as possible per method, so we keep our test methods small, meaning that we may end up with hundreds of methods. That's okay. We want to minimize our dependencies both between the tests. There can be none between the tests. And we want to minimize it on the client server connections, and careful about the database. And then we should be careful about what we create and how we delete it again. All right. So I'm going to test a queue. That's my first example. I will test an Mvvm application as my second example. So the queue, this is the interface for the queue. I hope you have looked up what a queue is about. I should have provided information, and you should have seen it in a previous topic. So the Enqueue method is to insert something into the queue. I can take something out. I can ask what is the next element in the queue. I can ask how far into a queue is an element. Is the queue empty? What is the size of the queue? And does the queue contain the element that I'm asking for? Element T, I'm missing a colon here. So T, again, it's a generic. You can write a class using T, and then when you instantiate the class, you can override the T just like you do with your array list. You say that your array lists, I didn't have an example there. Array list contains strings using the arrow things. Array list, arrow, string, arrow. So you have an array list containing strings, which means that the T will be replaced with string. This is just something we do. I don't want to go into too much detail here. So the Enqueue method, and it takes an element, and that could be E in my case, and it puts it at the end of the queue. Add the element to the back of the queue. If the element is null, an illegal argument exception is thrown, so that means my queue does not accept null element. And if the capacity of the queue is reached, I will get an illegal state exception. So this is a bounded queue, meaning that there's a maximum size, and unlike the array list, it will not expand when it reaches that size. So it's not a very useful queue, I think, but it's just so we have something slightly more interesting to test, because we have some more behavior. So we could do a large analysis of all the various cases for the Enqueue. I'm basically going to wing it, but we will try to keep in mind the boundary testing, the equivalence testing, and the branch testing. And maybe also the sump, 0, 1, many, and boundary, and the exception here, because we have exceptions that needs to be thrown. Now my colleague made a wonderful video about test-driven development where he really goes into detail about each test case. So I recommend you watch that as well. But that will end up being quite a few hours of video watching, so maybe you're not up for that. But I found it good. Okay, so the next step is that we do a few unit tests for this Enqueue. Okay, let me fish out IntelliJ. I have set it up here. I have a module for my queue test. I have another module for my login test, my Mvvm structure. It's a login system, which we will see later on. I have my package, my source folder with my queue, and inside my queue is a Q80T, so that's an interface, which I don't specifically need here. But I have made it just so you can see it for your for your exercises. It's easier to do when you have your interface, because then you can write one class and you're going to test multiple variations of my queue. So you will also be doing this for the exercises. At least when I'm doing this video, you will have that exercise to do the test for the queue. So I need to do some setup. Now the standard approach, the one I has been taught, is to you have all your code in the source folder, and I don't want to have my test in here because that doesn't really have anything to do with my program. So I want that separated, so I have a clear separation, right? A single responsibility, you might consider it. So I'm going to create a new folder, directory. I'm using alt insert. I just learned that from the other video from my colleague Ole. I will call it test. And you will see that the test is just a folder marked with nothing, so it's gray. IntelliJ marks the directories here in various ways to indicate different types. The dot here indicates a package. Blue square, it's a module. Blue, it's your source folder where you keep all your Java code. And this one, I want to mark this as a test source folder. And that means I have to mark directory as test sources root. So now it becomes green, and it will contain my test classes. Whenever I compile my program, it will also compile classes in here. All right, next step is to actually create a test. So let me just clear this out. I want to create a test for the Q80T, the interface. I could do it for the bounded array queue, but I just start here because these are the methods that I want to do. And I could create a class over here, create a similar package structure and create it manually, but I'm just going to cheat and say alt enter, and I want to create a test, and I get this window. And here's the first error that many students do. They do not, I suggest that you pick either JUnit 4 or 5. I don't know what the other stuff is. 3 is probably outdated. Test NG, I don't know. Don't use that. Be specific about JUnit 5 or 4, that's okay. You can provide a class name. I will just call it maybe QTest. I don't need to provide a superclass. I can create a destination package. It automatically picks the one from my test. So the package hierarchy of my test folder will be identical to my source folder, and I think that's probably a good idea. I can auto generate some stuff. I don't want that because I haven't had much success with IntelliJ trying to guess that, because it will just create a method called enqueue and dequeue and first and size and so on. And that's not what I need. I need many methods to test just one method. So I don't need this. I click OK. There we go. And you will see down here, test queue, right? So I have my queue test in a similar package structure. Now it already complains here. That means I have to press alt enter. I want to add JUnit 5.3 at the time of recording. Maybe you watch this video later and it's 5.4. I don't know. I want to add it to the class path. And it wants to download something. Download 2, I don't care, whatever. I click OK. Just fix whatever is broken in IntelliJ. Do your thing, your magic. Wiggle your wand. Whatever. Okay, it takes some time on my ancient slow computer. Hang on. And we're good to go. That is now imported. JUnit. Okay, that's probably fine. Okay, so I want to write my first test method. Where should we start? Hang on. All right, so we'll just start somewhere. I want to add an element to the queue and verify that it is then actually in the queue. Let's start there. I will say I need to create a method for this, public void. They always have to be void. You cannot have anything else than void. Added element is in queue. All right, and you cannot give it any arguments here as far as I know. So I try to provide a method name that indicates what this test is actually about. I will use the annotation test, and I have to import that. Alt enter. It will import the test, and I will just I can just change it with a star. So I want to import all my annotations here. I may need other. Okay. I will then create a test, a queue to use for my testing. I will create a queue, not a quest, a QAT. Let's just put a string in it. I will call it queue, and that will be equal to a new bounded array queue. And I need to give it a capacity here, so I will just say there's room for 5. Okay. I will then say queue. I want to enqueue A. So let's just say here arrange act assert. So first I arrange, that's the setup, right? Then I actually execute some functionality, that's the enqueue. Then I assert that the acting results in what I actually expect. So I will use the method assert true to say I can give it some yeah, that's probably okay. We will say queue contains A. All right. I have set it up. I have done some acting, execute functionality, and now I am asserting, I am verifying that my queue contains the element A. If I run this, you can see I have tiny arrows here. This will just run one test, and this will run the entire test class, everything in here. All my test cases. I will just run this here. And it takes a little time to build. Hang on. Yeah. Dependencies, setting up, all kind of stuff. It's now running my tests. And there we go. Okay, so I have my class QTest. I can create what is called a test suite. I don't know. A group of tests. So if I have multiple test classes, I can group them together. So that would mean I have a test class here with all the methods in. I would have another test class with all methods in. I have linked Untitled Learning to a tutorial on JUnit 5 that also mentioned test suites. Okay, so I can see one method. It's marked green here. So there's nothing, it succeeded. It passed. If I were to do this here, then I'm expecting something that I know it's not true. But if I run it again, now I'm just running one method, so I will not see all of them. If most of them succeeds, then there's no need to run them again. I just care about the one. And you will now see that it is yellow. And yellow means that my program did not actually break, but it did not result in the, whatever I expected it to. So when I inspect this here, I check the method. Okay, this here failed. The expected is that it's true. I actually got false out of whatever I gave it here. And I can see a stack trace. I can click here and say, okay, this is the line where it failed. So it gives me some information about what went wrong. I can probably give it a, I could not. Probably give it a message as well. Yeah. This is actually true. I made a mistake. I don't know. You can give it some kind of message that might be more interesting than whatever I've done here. And I can run again, and it should now also print out my message. Let's see what happens. Okay, and here we go. Right, so I want to change this back to A because that's what I actually expected in the first place. Okay, now I want to test that. So that's sort of my one. I can add one. Maybe I want to add many also. Public void add multiple elements to queue. All right. And I will say I need a queue again, so I can just steal this one. I will now say queue, I want to add A, B, and C, and D, and we assert true. We say queue contains A, B, C, D. Now I'm actually asserting multiple things here, which may not be a good idea, because if it fails here, then I don't know what's going on down here. I don't get any result about the rest of it. So again, the S part of symbols of zombies is keeping it simple. So that also means if we can minimize the number of asserts. But I'll just do this in any case, and I will run this again. And my tests both succeeded. So my queue is working so far. Okay, let us check out. Right, this is my too small here. So if the element null, I expect an illegal argument exception. Okay, so let's say no. I want to do. Let's skip that. Oh wait, I need to show you something else, because I've shown you the assert true. I want to say size is 4 after adding 4 elements. Okay, I will steal this again. So you see me stealing and copy pasting. Maybe that indicates that we can do this in a slightly better way. I will assert. So I can say assert true. I can do this I can do it like this. I would expect that the size is now 4. Q.size. Okay, so that's one way of doing it. I could also use another method that says assert equals, which takes 2 elements, or 2 arguments, and the first one, if I control P in here, I get up the. Right, so the first one is the expected, and then the second argument is what is actually given. So I give it 4, that's the expected, and we say q.size, that's the actual thing. So now this will be okay if the size is equal to 4. So these two here are basically doing the same thing. I just wanted to show you that we have the true, we also have equals, go away, yeah, equals, to test that 2 objects or 2 whatever are the same. So I'll just remove this one, there we go. Okay, let us run my tests again. All of them. We'll just go here, run tests. There we go. And there's run. My 3 methods are all green, so that's wonderful. All right, so I have put the test annotation here. I have to do that on top of all the methods that I want to run. If I remove this one and I run it again, you will see that it will not run this one here. It's also grayed out, so it's never used. So it's not picked up by the test framework, and the test is running, and I only get 2 out here. So I have to put the add test, and I have to do it with a capital T. This one does not exist. Add test. Okay. I can do something else. We have a few annotations, and the tutorial I linked goes through, all of them. I'll just show you a few. I have one here called before. You will see that there's actually a before. Okay, so before, that's JUnit 4, and I'm using JUnit 5, so I have a before all and before each. And before each will run, okay, let me just do here. I will say public void create queue. There we go. So this method here, because it's before each, it will run this method, then it will run this method, then it will run this method, then it will run this method here, and then my create queue, and then that one again. So this method is run before each of the test methods. If I go before all, it's just run once, and then all my test methods are run, and so on. So I will go before each, and then we will say I don't want that one. Put it up here, and I will just create a queue field, and it is of type that, and it contains strings. Okay, so instead of me having to duplicate this here every time, creating a new queue, sometimes that can be okay, but I can also just do it once up here, and then it's created for all of these. Now remember that if I do it before all, okay, so let's check out another thing here. I know it's getting a bit flighty, but I want before each. So I have before each method here, I have a clean queue. It's empty, and I will just run this. And then afterwards, I will say before all, and I will show you that we should not have dependencies between my tests, meaning that if I do something in one test, that should not affect the result of another test. So this works. If I say before all, I will create one queue once, and then I will run all the tests, and they will all use the same queue. So now we see a different approach here. We see that whatever I did in this test will be carried along to whatever happens down here. And now test ignored. That is really not what I expected. Test failed. Test ignored. Must be static unless the test class. Okay. Well, apparently that did not work as I expected it to. So that's good. You don't need it anyway. My point was just going to be that if I insert something here, and then I keep working on the same queue down here, then I will already have 4 elements, and I try to add 4 more, but there's only a capacity of 5, so I would have a dependency between my test that would make my test fail. Okay, so we have the before each. That means this method is run before each test. I will create another one because we now have the if the element is null, an illegal argument exception is thrown. So we do this here, test public void null argument results in illegal state exception. Okay, and we say queue.enqueue and null. That's what I want to do, right? And I can say I have another tool here. If I just do this here, so there are actually multiple approaches. Let's check them out. If I do this here, we should expect that this test fails, and this time it fails spectacularly. So it's actually red, meaning that the program broke. It's not only that some assert fails, but I actually get something that my program fails. So I get an exception here, and it is actually what I expect to happen because I am not allowed to put null in here. So how do I tell my test that this is okay? That it is okay that I produce an error. This is the expected error, and I can do it in multiple ways. The simple sort of dirty way, maybe I shouldn't even show you, but I can just do this, and that means I will catch the exception, nothing will happen, and my program will terminate fine, and I can run it, and it should now be green because I do not throw an exception out of this method. So that's good, right? It's maybe not entirely wonderful, but I just catch everything. So if I were to throw another exception, and that would actually be a problem, then this would still indicate that it's okay. Okay, let's try something else. This is what we can do in hang on. Okay, so if you were to use JUnit 4, you can do this. Just to be sure, .class, yes. Okay, it does not recognize it in JUnit 5, so they have removed that again. But this just means that I expect an illegal state exception to be thrown from this method here, and that would make it okay. And also, if I do not throw an illegal state exception, then the test would fail. So what we do instead now, because this here indicates that this can only happen at the end of the method, so I cannot test anything else afterwards. So we have done my, if we follow the arrange act assert, then I'm doing the arrange part up here now. I'm doing the acting part, and then I want to assert something, and I want to assert throws, and I expect to get an illegal state exception .class, and I expect that to get that whenever I do this method call here. Okay. All right, and it complains about something. What's going on? Execute find the right. Okay, yeah. So it needs a lambda expression. So I'm not really giving it any. I could. Yeah. So you just have to put this in front of it. So it will execute this and expect an illegal argument exception to be thrown. And we will do this here, and I can run it. And illegal state. It should be argument, right? Illegal argument. Let's just give it another go. Okay, so now it's green. That's good. So I mentioned that we should sort of isolate our test, keep them simple, and you will see that I'm using the Enqueue method, and I'm also using the contains method. I'm using the Enqueue method and the size method. It cannot always be avoided that, sometimes in order to verify this part, I have to use another method, assuming that this method works. If it doesn't work, then I will get an error, and then obviously I will see whether it's this method or that method that fails, but try to keep it simple. For the enqueue, I also want to test the maximum capacity. That's not what we wanted. Test, right? Because when I insert, I'm giving my queue a capacity of 5, and if I insert an element number 6, then the capacity is reached and an illegal state exception is thrown. So let's try that out. Public void full queue results in illegal state exception, and I should probably rename this one up here because it's actually an argument, illegal argument. There we go. And I will say I have my arrange up here. I will do maybe the arrange could also be considered to enqueue A, B, C, D, E. Okay, so now I have set up. I now want to say if I add another element, that would be the 6th element, and I assume that it will then throw the illegal state exception. So I will assert throws illegal state exception dot class. We give it a lambda expression and say queue, enqueue, whatever. Right, it doesn't matter. And I will run this test, and hopefully it will succeed. And also be green. Yeah. Okay, so we have the assert true, we have assert equals, we have assert throws. I have an assert false test, public void. What can I assert that is false? Empty queue doesn't contain element A. Alright, so I have nothing in my queue. I can just assert false queue.contains A. Right? Obviously, when my queue is false, there should be nothing in it, so I can assert false. And the last tool, let's just steal this one. I don't really, usually it was, well, my previous examples, full queue results in an illegal state exception version 2. In my previous examples, when you used JUnit 4 and you didn't have this assert throws, you could do this in a different way. So this is the part that we expect to fail. I would surround that with a try catch. Okay, so here's the thinking. I am allowed to put in 5 elements. If I put in the 5 elements, I put in the 6th element, that should throw an exception, go down here and catch that exception and do nothing about it, and then just run out, terminate the method. That would be okay. If I do not throw the exception from here, but actually move on to the next line, then something is wrong. I should not be able to execute anything in this line. If an exception is thrown from here, it would skip straight to the catch clause. So I could say here, if I reach this point, should not be able to insert 6th element. Right? Meaning that if I do not throw an exception here, it would move on to execute the next line, and I could say you should fail if you reach this part. So let me just comment this one out so we actually see what happens, because here I manually tell my test to fail. So you might need this if you... I can't really come up with a good example, but maybe you need to fail your test manually. Okay, so it actually fails. Here you can see that it's yellow dotted underline, and it's yellow over here, it fails, and I get the should not be able to insert 6th element. So that's I reached a point in my code which I should not be able to reach, and so we fail it. If I then actually do what I expect here, I put 5 elements in, I try to put in the 6th, then it shouldn't reach the fail, it should throw an exception, meaning we skip to the catch clause here instead. Alright, now it succeeds. Okay, so the first example here is already getting pretty long, so let me just check. The methods we have talked about: true, equals, false, fail, and assert throws, and those are the main tools that you're going to need. As I mentioned, I have linked to now I hope I don't have any embarrassing tabs open. There's a JUnit 5 tutorial which you can look up and read about. There are more annotations you can use like these. There are other asserts and other things. There are good suggestions on how to write tests and so on. So that's for the for the unit testing. Okay, so let us move on. Right, so you see I have written a few tests here just to test that the enqueue, and I haven't really done the enqueue thoroughly, but I tried to use the 0 or 1. That's the border. I can insert 1. I tried the many. I also test the other border here. That's the end. So when it gets full, we have some boundary testing here, and another approach for the boundary testing I am doing. We might also consider that this here. That's the branch testing. If I were to actually look at the Enqueue method, I go here and I go here, we would see, I can see the branches. Okay, if it's null, If the queue is null, we do this. Okay, but the queue cannot. No, it can actually be null. But that's not something that I can manually control. If the element is null, then we throw an illegal argument exception. Null is not allowed. So that happens here. The enqueue is fairly simple. The dequeue is a little bit more complicated because I'm moving elements around, so maybe that's more interesting to check and to verify that the count is updated, so that when I check the size, I get the actual count and not just the length of the array, because that will always be capacity 5, no matter how many elements are actually in it. So we did the branch testing by looking at the code and see, well, also the documentation, because it stated that it could not accept null. So let us get back to this part here, and I will just find my trusty lazy pointer. There we go. Okay, we talked about the AAA. We tested as little as possible. You saw me doing small tests. I tried to keep dependencies to a minimum, and I created everything I needed. And that reminds me, that's also deleted again. So if I needed to, I could go after each. And this method would then be called clear queue. It's not really necessary, but I could say queue dot. There's not even a clear method on it. On a list, I would have a clear that would remove all elements from the queue. Okay, so before each and after each, if you need to clean up again. If this was a database, before each you would set up your database with all your test data. After each, you would break down your database, completely drop all tables. So that happens between each test. Okay. So we got to this point, and the next part is then the Mvvm. I think we'll just, I'll try to make it quick. So the Mvvm structure creates a clear separation between what is UI in our view and our controller, the fxml file and our controller, and everything else. So that's basically the view model and maybe a model and whatever else is down here. In my example here, it will be a local system, no client server system. So it will just be a view model and a model. Right. So the plan here is I don't want to click around in the UI, insert text and click OK buttons and check marks and insert dates and birthdays and whatever. So we are stripping away the unnecessary classes and we just want to test the functionality. So I don't want to actually run the system and use the UI. I just want to call methods on my view models instead. And my program sort of looks like this, very simplified version. There is a view for logging in. It's a login system. That's all you can do with it. There's a view for creating a user. There's a view for changing password of existing users. And then there's a simple view, which is just the result when you have successfully logged in. I don't know what this is doing down here. These three have view models. They know about login model. The login model is set up like this because this is also an exercise. So I'm going to have multiple login model in memory implementations, versions A, B, C, D, and so on. And they have some shared functionality which is in the login model base. So this is not me trying to indicate that you should do something similar in your projects. It's just what makes sense for this specific one, because I have multiple model implementations for the exercise. They know about users. That's a list of users. Okay. We're going to test the logic. There's some rules in place for passwords and usernames and whatever. So we're going to access the view models, and they should then call methods on the model, and we get a result back. So this might be considered an integration testing using a JUnit approach. We write code that can do integration testing because we're verifying that the login view model can work together with the login model. So multiple classes working together, we test that they integrate correctly. All right. So let's just check out what the system actually does. I have it up here. I can actually run it, run login, hopefully. And I should get a view in just a second. Yeah, it's hidden somewhere, okay. And I don't really remember whether I actually hard-coded any, so let me just check. I have hard-coded some usernames. Trolls, Trolls1. So if I log in with Trolls, Trolls1, log in, I get to this one and I can exit. That should probably have been a back button because now I have to run it again. And okay. So there are some rules in place, and there's a specification. So this is sort of like a, I don't know, I can look at the code, but we're going to test it according to the documentation. So I will just find the description of this one. And I have running this again, and you can see that I can register. Let me just call it other trolls, and if I create a password, that's too simple. I want to create password length must be more than 8. Okay, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Oh, they must match. Okay, all the complaint. So much trouble. Must contain at least one uppercase letter. Okay, A. At least one lowercase letter. What an annoying program. There we go. And now I can remember my password. Other trolls. 1, 2, 3, 4, 5, 6, 7, 8. Uppercase A, lowercase Z, and I can log in. And okay, there we go. All right. So there are some rules in place, and I get messages whenever I do not follow those rules. So let me just find the specification. Hang on. All right, we have it here. So this is the specification, the document describing the rules about my login system. And there are 4 screens. When creating a user, the username must be between 4 and 14, must not be empty. That's sort of implied by this one. Cannot contain this character. Interesting. Be unique, a username cannot appear twice. Okay, so there are some rules for the username. Then there are rules for the password. And case sensitive. There's some behavior description. There are some error messages. Okay, if the username is empty, we get this back. If that's blah 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 blah, so on, blah blah blah. And here I actually have an example of a test case documentation, which we might spend a second or 3 on. Probably you see these in the software engineering course, but this is how you can document a test case. This is one approach at least. I give it a name. There should probably be an ID as well. It's often easier. I give specific steps. This is for logging in. Have valid login. Maybe I should also give it specific data. That's always nice. At my previous job, I had a very strange error about something. There was some input that didn't work, and I could not reproduce the test. And then because they didn't have the specific data, and it took some while, and then I got the actual data, and it turned out that it was their subdivision in Spain, and that they had some strange accented letter that my encoding was not able to read, so that messed up my system because they were using some Spanish letter. So that's the motivation for actually giving the specific data here. Okay, that's super annoying. Stop that. I don't want to log in. Right? Insert username. Jesus Christ. Okay, and this one is Trolls1 also with the password. So insert password, click login button. And sometimes we see the swim lanes. So steps, I have what does the user do? How does the system react? What does the user do? How does the system react? And then I have a table here, expected outcome. You're shown the login screen, or the result label says OK. So this is if you do it through the UI. This is when I do it through the code. So that's also username not found, error messages. Here, there's some description about the result label shows OK, so we can use that to test. And then I can check mark here if it passed. If I have the swim lane, I can check for each step. Yes, the system correctly responds. Next step, system correctly responds, and so on. So this is one way of documenting the tests. Okay, So we will do a simple test of trying to, we'll work with the create user. Okay, and I don't want to test all the various cases, so we want to create a test case for this. And I want to do it with a, what is I'm testing? I'm testing my, we're testing create user. So let's go in here, and we're testing this one. And I will alt enter, I will create a test. I will say JUnit 5, that's magnificent. That's probably okay. I don't want to also generate whatever. Yes. Okay. And assertions. So I have to add to class path. So I probably have an external library down here. That's JUnit 5.3. And if I were to go up here, project structure, I can see that my queue test has this. My login test does not. So I could just say over here library Java. Not what I expected to see. Yeah, okay. So we will just alt enter here and add to class path. Okay, wonderful. Now I want to use this without the GUI. So I want to create a test, and I want to, let's say, void setup. So this is not a test, it's a before each. So this is my setup, and in the end I want to have a, I want to have a private create user view model. VM, we just call it VM. So I have to set this up so that it works. That means I need a login model. Yeah, it's my model. It's a new login model in memory. You see I have various versions. One of them works correctly and the other ones have various errors in them. So that's your exercise, trying to find those errors. I pick the one that works. There we go. I want to say, let me just see. I do think I have a, in the base perhaps, there is a populate model with dummy users, which should be capital U. Not super important. Let's just with that in. Yeah. Okay, where did my test go? Create user VM test. Here we go. Yeah, so I want to populate. We say, then I cannot do it through the interface. It is a login model in memory, login model base, that one. And I want to populate. There we go. So now I actually have some users, and then I want to say VM equals to new create user VM, and I give it my model. That's my setup. Okay, so it's a bit more fluffy here, but let's see. I want to create a valid user test. Public void create valid user. It should be other tools, and the password should be, I just checked that this one worked, AZ. Okay, so how do I do this? I say in my view model I want to hook into the string properties and use those. So there's a username and passwords and a result. All right, so these are the string properties that I can interact with, and I can then call the methods. So I want to create string properties in my test to bind them to these, and then I can call a method. I can set values so that I pretend that my test class is interacting with my view model just like my controller would interact with the view model. My view model here does not care who has bound which property into its properties. It could be my controller, right? You create user controller, or it could be my test. It does not care. It just cares that we put some data in it. We might call a method. It might update some data, and then it doesn't care about anything else. And let me just go back here. So we say I need 4 string properties. String property username, not a new, that kind of new, yeah. And I need a password again, and result. password again, result. Okay, then I want to bind these to the view model. We say view model, I have a username property, bind bidirectional to my username. I have view model password property, bind it. Bidirectional, that's probably okay. I don't really need bidirectional. Oh, I do need bidirectional, I think. That's probably okay. Password, again, we want to bind it to my other, bind bidirectional to my password again. There we go. And I need my view model result. What did I call it? Create user result property, this one. And we bind it bidirectional to the result. Okay, so this is my range. I'm setting stuff up. Now I need to do the acting. Okay, so what do I actually need to do? I need to create a test where I insert this as the username and this is the password, and we want to let's just call it successful to indicate that this should actually succeed. So this should be both username, both the password and the other password. So the acting part here is we say username dot set value. I set it to other roles, and then we say password. I want to set value. I don't know if set or set value, it probably doesn't make a difference. I just steal this here. I did not steal that, very good. Here we go. Yep. And the password again. Okay. So now I have set up, and then we just need to actually call the method. I want to create a user, attempt create user. There we go. That is my acting. I have done everything I need to do. Then we need to assert. So what is it that I now expect? I expect that the result is okay. We say assert true. Result dot get value, and I want to, maybe I want to go equals instead, result equals, and I say the first thing, this is what I actually expect. I expect okay. I could also say, now let's start with this one. Okay, so I have done my setup. I have hooked into the view model with my own string properties. So here I am playing the controller. I am acting as though I am the controller. The view model does not care which properties are bound to its property. It does not care who calls the attempt create user. Usually it's the controller. Right now it's my test class. And then we just read the result back again. Let's run it. And it's running, and I get my result here, and it is successful. Everything is good. I actually get the okay result back. Just to show you if I made a mistake here, intentionally, obviously. I would never make unintentional mistakes. Yeah, I don't know. Maybe that happens. Now it actually fails, and I see I expect okay. I actually get back passwords do not match, and I can just quickly verify, okay, I made a mistake. But if I still have this correct here and I do get the wrong error back, then I probably have something that I need to look at in my code. So if I have some more or less complicated functionality in my model, I can hook into it like this and test that functionality. And if I change the functionality, I can just quickly run all my unit tests again. I have a bunch of rules that can be tested. Right? I have just tested that I can actually log in or create when I do it correctly. I have not verified it's not empty. I have not verified what happens if I insert a hash somewhere. What if I try to create the same username twice. What happens here? I could just see, I probably get a result back. Let's see, what do I actually expect back? Error messages, username not found, creating user. It contains username exists. I expect this one, username already exists. Let me see, username already exists. So that's actually what I get back again. Okay, I could here also say clear fields and then verify afterwards that my properties here are now empty. Assert equals like that, username get value like that, right? Then I verify this, that the clear fields also works. But again, keeping it simple, I may want to do that in a separate method. All right, so I don't think I will show you more for this part here, because it's getting a very long video. So let me just go back to my slideshow. You have seen this. Just remember that we can set up our view models and hook into it like this. You can also do your server model. You can test it in a similar way. Maybe you do not have a view model, but then you just call methods on your server model if it has any logic. If you want to test a database, you can do it through your data access objects or whichever class accesses the database. So this is what we tested. Can I create a user? And we had the rules, and I just showed you the successful one, but remember that we also need to test the rainy, cloudy, non-sunny, stormy, snowy scenarios. And we did this part, I've coded that, and we have reached this part where I'm saying thank you for watching and lasting the entire video. All right.